Miniature circuit breaker MCB. What is a miniature circuit breaker? How it works? Types of MCB. In this video, we will talk about what is a miniature circuit breaker? Miniature circuit breaker construction. How does a miniature circuit breaker work? Types of miniature circuit breaker. Typical uses for domestic MCBs. What is a miniature circuit breaker? A miniature circuit breaker MCB is an automatic, resettable switch that protects electrical circuits. Its primary purpose is to automatically turn off the power when it detects an overcurrent or a short circuit, thus protecting appliances from damage and preventing accidents. Miniature circuit breaker construction. The construction of miniature circuit breakers is extremely simple, robust, and requires no maintenance. Generally, the MCB is not repaired or maintained, rather it is replaced with a new one when needed. A miniature circuit breaker usually contains the parts shown. Operating handle. Lower terminal outgoing load. Electromagnetic protection. Moving contact. Fixed contact. Arc chamber. DIN rail holder. Thermal protection by metal. Upper terminal incoming supply. Operating mechanism. Miniature circuit breaker work. An MCB is designed to protect against both overloading and short-circuiting. These are detected differently using separate processes. Overload protection is provided by the bimetallic strip using thermal operation, whereas short-circuit protection is provided by the tripping coil via electromagnetic operation. Excess current causes the bimetallic strip within the MCB to heat, bend, and trip. This releases a switch which moves the electrical contact points apart to confine the arc. The arc is divided and cooled by an insulated metal strip called the arc chute. The contacts close again once the fault has been fixed and the MCBs are reset. How does a miniature circuit breaker work? MCBs have two modes of operation: thermal overload protection to protect equipment from long-term overcurrent damage and magnetic short-circuit protection to protect equipment against very high fault current. Types of miniature circuit breaker. Miniature circuit breakers are categorized into different types, defined by trip curves. These curves illustrate how quickly an MCB will trip in response to an overcurrent. Understanding trip curves is crucial for selecting the appropriate MCB type for specific applications. Each type has a unique curve that dictates its sensitivity to overcurrents, ensuring that the MCB provides optimal protection without unnecessary tripping. Type A circuit breaker. Type A circuit breakers are the most sensitive. They trip when the current flowing through exceeds the rated current by a small margin. Trip sensitivity. Trips at 2 to 3 times the rated current. Common applications, primarily used for highly sensitive electronic equipment, such as semiconductors and circuits with long cable lengths where voltage drops can be a concern. Type B circuit breaker. Type B MCBs offer a moderate level of sensitivity and are the most common type found in domestic or residential installations. Trip sensitivity. Trips at 3 to 5 times the rated current. Common applications. Suitable for protecting general household circuits, including lighting, sockets, and small appliances like refrigerators and washing machines. Type C circuit breaker. Type C MCBs have a higher trip threshold compared to Type B and are designed to handle moderate inrush currents. Trip sensitivity. Trips at 5 to 10 times the rated current. Common applications. Commonly used in commercial and industrial settings for circuits with inductive loads, such as motors, transformers, and fluorescent lighting. Type D circuit breaker. Type D MCBs are the least sensitive type and are specifically designed to handle very high inrush currents. Trip sensitivity. Trips at 10 to 20 times the rated current. Common applications. Primarily used in industrial environments for heavy-duty applications, such as large motors, X-ray machines, and welding equipment, where high starting currents are expected. Typical uses for domestic MCBs. Whilst every installation is different and should always be designed by the fully qualified professional electrician on site, there are some standards which most domestic wiring schemes adhere to. Amp. Standard lighting circuits. 10 amp. Large lighting circuits, though these are becoming rarer in domestic settings as technology and trends move towards lower energy lighting sources such as LED. (16 amp and 20 amp). Depending on the power rating, these are both commonly used for immersion heaters and boilers. 32 amp. Ring final. The technical term for your power circuit or sockets. 40 amp. Cookers electric hobs small showers.
Thanks for watching. Don't forget to subscribe and activate the bell button. See you in other videos. Channel Team.